In this video, we have a look at the definition for radians. We also look at the conversions between angles which are measured in degrees into radian measure, and also how to convert from angles in radians to degrees. Let's first of all look at a unit circle, and it's called a unit circle because it has a radius of 1 unit. If we place an arc in that circle such that the arc length is 1 unit, in other words it matches the radius, then the angle which subtends the arc, in other words faces the arc, is 1 radian. Now that's also true for other measurements. If you have a radius of 2 units and the arc length is 2 units, then the angle which subtends the arc is 1 radian. Let's now extend that arc, so we're looking at the circumference of the circle. So the circumference formula is 2 pi r, and given the radius is 1, that means the circumference is equal to 2 pi units. So that means that the angle, which is the revolution all the way around the circle, is 2 pi radians. We can say this because in a unit circle, the distance around the circle, in other words the arc length, matches the angle which subtends it. Now let's consider the arc length and matching angle around half a circle. We'll first of all form a straight line here to give us a straight angle of 180 degrees. Now the arc length will be a half of what it was around the circumference of the circle, in other words pi units. So the angle is pi radians. Again, we can say that because in a unit circle the distance around the arc matches the angle which subtends that arc when we're measuring in radians. This gives us a key reference when we're forming our conversions. We note that an angle which is 180 degrees matches an angle which is pi radians. Let's now look at the conversion from angles in degrees to angles into radian measure. Now the first thing we want to consider is what is the fraction that the angle in degrees is out of 180. So for example, if it's a half of 180 degrees, it'll be a half of pi in radians. And so at the end of the formula we multiply that fraction by pi. Let's have a look at some examples. We'll start by looking at 30 degrees. So in our formula, we express that as a fraction of 180, so 30 over 180 multiplied by pi. We know that 30 goes into itself once, and it also goes into 180 6 times. So 30 degrees is 1/6 of 180 degrees, or in radians, 1/6 of pi, which is pi on 6 radians. Now let's have a look at 45 degrees. We do the same thing and express it as a fraction of 180 multiplied by pi. We know that 45 goes into itself once and into 180 4 times. So 45 degrees is 1/4 of 180 degrees, or in radians, 1/4 of pi, or pi on 4. In the next example, we look at 150 degrees. As before, we express that as a fraction of 180. Now, 150 does not go into 180. But 30 degrees goes into it 5 times, and 30 goes into 180 6 times. So we can simplify that fraction to 5/6. So the angle in radians is 5 pi on 6. When converting from radians to degrees, we follow the same concept, but this time we're looking at what is the angle as a fraction of pi. And when we work out that fraction, we then multiply it by 180. So let's have a look at the example here where we're dealing with a radians measure of 3 pi on 4. We express that as a fraction of pi multiplied by 180. Now we can take the 4, which is in the denominator of the top line of the fraction, down to the bottom and have 3 pi on 4 pi multiplied by 180. Now the pi's will cancel with each other. 4 goes into itself once and goes into 180 45 times. And when we multiply that out, we get 135 degrees. One small thing to note is you'll always see angles expressed in degrees with the degree symbol, but quite often angles which are expressed in radian measure won't show the symbol. So you might see a capital R or the word radians, but sometimes you'll just see a number representing the angle. That means it's in radian measure.